Hi, this is Dr. Khalid Jaber. I will be recording Chapter 1, Introduction to Software Engineering. All right, this is some of the key things that I will be covering in this chapter. What is software engineering and the software development life cycle, software development approaches, roles in software engineering, trends in modern software engineering, tools and technologies also in software engineering. So start by defining what is the software engineering. Software engineering is the application of engineering principles to design, develop, test, and maintain software systems. Now, software engineering has been for a while, around for a while. Here we are listing some of the history and evolution for software engineering. As you see, we have things that started in 1960s. This is where software engineering terms start becoming known, and so etc. I'm not going to go over the list. You can read it in your own. All right, now the second topic here is that software engineering, which now we're trying to focus on the modern things in software engineering. These are some of the key concepts or characteristics that you can see as part of software engineering. Starting with the first one, modularity. What it means here is that this is usually like for software design, you are breaking the system into manageable pieces, microservices. The goal here is that you want to reduce the complexity. When you break things in the design, you are reducing the complexity. Abstractions, it focuses in the problem solving and not the details. So if you took the object-oriented class, this is related to a class, for example, and the methods of the class. So the data in the method, nobody can access it from outside. So it's accessed by the method itself. So the details, the data is hidden from the outsider. Automation here is using automation as part of, as part of software engineering. This is very important. Collaborations, this is mainly for teams to collaborate and work together. And for example, the teams, who are writing the code, they can collaborate using virtual control like Git as a framework to use to communicate. This is about writing the code. Security is a very important topic and in software engineering now, and reliability, and it is continuing to there is continuing improvements into these two areas. Artificial intelligence and machine learning, this is becoming very hot topic in these days. And approaches and tools, also using tools like Agile is one of the methodologies, DevOps, Docker, etc. I will be covering these going forward in this lecture tonight. Right. Moving on. So, what's the difference between programming and software engineering? There is a difference. Programming, mainly here you write the code, you may use a programming language, which is like Java, Python, etc. Software engineering is different. It's applying the principles to design and develop the software and maintain it and deploy it, etc. Key differences: there are some programming tools and there are some also software engineering tools. Programming tools like these, like for example, using an IDE, which is integrated development environment. This is to write the code and compile it and debug it. For example, using Visual Studio, etc. Software engineering tools is using tools to help you to develop the software, design it, and deploy it, etc. And capture the requirements. There is one of the important tools that is currently used is called Jira, and there is also some like version control tools, etc. Also, the knowledge is needed as part of software engineering, and it is needed to know the methodologies and the approaches that are used in software engineering. Now, the second topic here is that the software development life cycle, mainly it's a life cycle. For example, like even human beings, us, we have a life cycle. We're born, and then we become kids, and then we become adults, teenagers actually, and then adults, and then etc. etc. So there is a life cycle. We go through stages, and that's where is the software also developing the software. It goes into 3 stages here and phases. The first one is that this is where we start collecting the requirements and analyzing the requirements. That's the first phase. The second one, when we have the requirements, we go into the design. This is where we design design the software, we design the components and the modules and etc. And then after that, we go into the coding, the third phase, which is here writing the code, etc., doing some testing, unit testing. And then after we write the code, we do the full testing where we test the system end to end. And then when the system passes, okay, it's ready to be deployed in the production environment, in the field actually, for the customers to use. This is where it's deployment. And then after we deploy the software, after that phase here, we get into the maintenance. Maintenance here is that the customer, there are some, after you deploy the code in the field, okay, there are maybe some defects that needs to be fixed. And as part of that, also as part of the maintenance phase, which is that sometimes the customer, they need to enhance, some of the functionalities needs to be changed, some of the features, maybe they need to add more, they need, etc. So this is where his maintenance is needed. Now, next we'll talk about software development approaches. This is a very important topic as part of software engineering. The first one, which is called waterfall model. By the way, the waterfall model is sometimes people they say they call it like software development cycle. Let me go to the next slide here and show you. There's a diagram here I put together here. Okay, so it's a traditional way of developing software. First, you start with the requirements. When you finish capturing the requirements, you go into the design. When you finish the design, you go into the coding, which is, we say, development here. And then when you finish the coding, you do the testing. And then when you finish the testing, you deploy the code, and then you do the maintenance. As you see, there is some advantages and disadvantages in this model. This one has been used for a while, and it's kind of an old way of developing software now. Each phase, the bad thing about this model here is that, okay, you cannot do things in parallel. Okay, so that you have to finish the requirements, and then after that you go to the design, and again you have to finish all the design for all of the requirements, and then after that you do the coding, etc., etc. Some of the advantages, it is very clear. I mean, it is a clear process. It is known that I know to requirements, I go to requirements, and then design. So the process itself, or the model itself, it's clear going from one phase to another. The second methodology is called Agile, and this is what is currently used in the industry. And this is developed by 17 people. They defined, that was in 2001. So they met and they defined principles or guidelines, and it is called also Agile Manifesto. So these are, as you see here, I am listing here the 4 key principles or guidelines for developing software. The focus in those, the first one focuses in that people who are working in developing the software, the developer, the tester, the people who are deploying the code, the customer, so all of them, they need to communicate and interact with each other. This is very important. The second one is that, okay, we wanted to start, with the software is considered that a successful software, okay, when the software starts, running the software, when we execute the software here. So the focus in delivering functional software with minimal useful documentation here. So the key here is that the focus is that, that it is very important to develop software that runs rather than spending more time just coming up with documentations and writing documentations. The third one is customer collaboration. This is very key things and important, as that what Agile came with. Earlier in the waterfall model, the one we talked about before, the customer, we meet with the customer at the requirements phase, and then we spend the time with the customer to understand the requirements. But then after that, we do not see the customer and communicate with the customer till we deliver the code, which is in the deployment part, and the deployment phase. Now, Agile improved in this, okay, and that's where is the strength and the power of Agile. They wanted the customer to be partner while we are going through the software development. So this is where is that, not just only in the requirements, we want to be engaged. We want to engage the customer. We want to engage the customer while we are going through software development. We develop something, we show the customer what we developed, we get some comments and feedback, and we go to the next phase, etc., next iteration, etc. So Agile focuses in building the software in iterations, in for example, like a month or 2 weeks iterations. So I will be talking more about, when I talk about the Scrum here. So let me get to the to the next third model here, which is the third approach, is called the Scrum. Now, Scrum, okay, it's a framework that implemented the Agile. So Agile mainly defined the principles and guidelines, okay? But Scrum is defined to implement those guidelines, and people now they are using Scrum, okay, which is an implementation of Agile. This is very key thing to understand. Okay, that's the difference between Agile and then the Scrum. Agile is the principles, okay, provide principles, but the Scrum is the actual implementation of those principles. So with respect to the Scrum here, Scrum let me show next slide actually, because it has better kind of view and information to explain what's Scrum here. Scrum, as I said, is a framework. Scrum, they defined 3 roles actually. They define the product owner. The product owner works with the customer to define the requirements, and then the Scrum Master is kind of the project manager, manages the development, and then also the development team, the people who write the code and test it, deploy, etc. So if you see in the bottom here, okay, in the left hand side, I have like a table which is a sprint 1, sprint 2. Sprint is an iteration. So in a Scrum, we develop software based on iterations, or as we call it, iteration is the same thing called a sprint. So sprint and iteration is the same thing here. So for the the sprint or iteration, it is less than a month, maximum a month actually. But what is commonly used in the industry, the iteration or the sprint is 2 weeks. So this is how it works. If you look in the actual diagram here, in the drawing, you see like the product owner, there is like a product backlog. Product backlog is these are the requirements. So this is a list where the product owner works with the customer, and then they define the requirements and they put them in the backlog, and they prioritize them, which one needs to do for first and second, etc. And now after that, when we start a sprint is usually 10 days here. Although we say 2 weeks, which is 14 days, but because of the weekends, so the working days are 10 days, like Monday, Tuesday, Wednesday, Thursday, Friday, 5 days, and another 5 days gives you 10 days. Okay, so this is starting at the first day of the sprint 1, for example. This is where is the team, the product owner, the Scrum Master, which is the one who manages and kind of a project manager here, and then also the development team together, they meet and they start planning the sprint, which is where they start pulling the requirements from the backlog, and then they pull requirements that is enough that they can finish in 10 days. So maybe they pull like 3 requirements or 4 requirements based on how much they can finish, and that's in day 1. They define what they need to do, they pull what they need to do, and then after that, in 10 days they develop the code for those requirements here. Every day they will have a meeting which is called Daily Scrum. Daily Scrum is that the team together, they meet for 15 minutes only, just maximum 15 minutes, whereas it's kind of a status reporting. Everybody in the team, they will report that, well, this is what I did yesterday, and this is what I'm going to do today, and these are the issues that I have. So everybody hears the others, okay, so they understand and they communicate what is the status and who's doing and what, who's working on what, etc. So in the last day, which is the 10th day of the sprint, this is where is that the development is finished. Now this is where they bring the customer, and then they meet with the customer and they show the customer, they run the software, they run what they developed so that the customer see it in action. And then the customer here, if they have any changes they want or that needs to be made, they will tell the team that these are the things I wanted to be changed. So in the next sprint, when they start, they go ahead, the team, and they go ahead and then make those changes with the customer requested. This is what's good, because every sprint you meet with the customer and you show them what you developed. So you show them the software. The disadvantage of the waterfall model, which I mentioned earlier, is that you have to wait all the way till you finish all of the requirements. Maybe you develop the software in 9 months or 6 months or a year, etc. But then at that time, you show it to the customer. The customer, when they see it, well, I didn't like this. Okay, this feature shouldn't work this way. So it becomes very hard to change the code, because maybe we have hundreds of lines of code or thousands of lines of code. So this is what is agile, is very powerful, because we bring the customer after each iteration presentation or after each sprint, we show them what we developed for them, and then we also get their comments, and then we go ahead and make the changes as needed. So this is a key things with respect to the Scrum here. So what I'm going to do actually here, okay, because I'm recording this chapter in 2 parts, so it makes it easier for you as a student to download the recording, because sometimes if you have a bad internet or you have a low speed internet, I don't need to make a big recording or a long recording. Actually, that becomes hard for you to download. So I'll stop now, and then I will record another session, which is part 2, after this one here.